Hello, my name is Mark Payne. I'm from the Danish Technical University here in Copenhagen, and I'm going to be presenting you today the blue whiting spawning habitat forecast for this year, 2019. And I'd like to start by acknowledging our funding agencies that have provided the funding for this work, in particular the Horizon 2020 project Blue Action and the EU FP7 project NARCLIM. And to start things off, I'd like to simply give you the forecast for this year, which is shown here on this map, where the colours correspond to the expected habitat distribution for 2019. And in particular, we're forecasting that the habitat will be very much compacted up here against the continental shelf edge, and that there'll be little or no spawning out here on the Rockall Plateau region. So how do we come to this forecast? Well, as I'm sure you may be aware, blue whiting is a small mesopelagic fish that is found in the North Atlantic, and that forms the basis for a very large and profitable commercial fishery. The species spawns up here in the feeds up here in the Norwegian Sea during summer and autumn, and also overwinters there before migrating southwards to the Rockall Trough region in late winter, early spring, where it spawns, before returning again to the feeding areas in late spring and summer. And what's particularly interesting about this species is that there's a substantial amount of variation in the distribution of the spawning habitat that we see. And we can see this based on results from the International Blue Whiting Spawning Stock Survey, a scientific survey that's designed to monitor the abundance of this particular stock. And so out on the left-hand side here, we have the results from the 2007 survey, where we see a very expanded distribution with lots of fish out on the Rockall Plateau region. Whereas in 2013, we have a very compacted distribution up against the continental shelf edge. And so we can really see the regions where the differences are here on the Rockall Plateau region, where we had plenty of fish in 2007, but essentially absence in 2013. And so if we're trying to either perform a commercial fishery on this particular population, or in particular trying to design a scientific survey to monitor its abundance, it would be very nice to have a piece of prior information about this distribution and which of these various modes of distribution we can expect. And so that's the question that we've asked. Can we actually predict these distribution shifts and the changes between these modes? To examine this question, we've used data from the continuous plankton recorder, a picture of which is shown here. And we have data starting from 1951 running up to 2005. And these are observations of fish larvae, and in particular of blue whiting larvae. We have around 35,000 observations in total in this region to the west of Great Britain and the island of Ireland. And of those 35,000 observations, there's around about 1,100 that are presence observations of blue whiting. And so we can treat this data in terms of its presence-absence nature and use it to develop a so-called species distribution model. And the idea of this is that we relate the distribution to a series of environmental variables that characterize the niche of this particular species. And I'll just run you through those quickly. First of all, we have an interaction between latitude and the day of year, and this accounts for the migration from the feeding areas to spawning and back again, and the fact that it's both latitude and time dependent. We also need to account for the sampling efficiency of the continuous plankton recorder, because this is dependent on the amount of light, and we've included therefore a solar elevation term to account for that. Blue whiting, as I also mentioned earlier, are a mesopelagic fish, and so we therefore need to account for the depth, because this organism primarily occurs between 250 and 600 metres down in the water column. And so in terms of environmental factors, we've focused primarily on temperature and salinity as the main explanatory variables. And it's really salinity and the interannual changes in salinity that can really account for much of the variability that I've shown you previously. And so we've gone through this analysis and verified the model, showed it's skillful. And we've actually written this up and published it recently in the journal Fisheries Oceanography. You can see the front page of it here if you're interested in reading more of the scientific technical details. what we've now then done is we've taken this model and actually operationalized it and used to produce a forecast system of the distribution of blue whiting. We did this for the first time a year ago now, in January 2018. And this is the forecast sheet that we produced detailing both the expected distribution, but also the technical details and the scientific rationale for how we came to those conclusions. But of course, it's very easy to make a forecast. The challenge is making one that's actually correct. And so now we're actually able to verify this forecast because we have the observations from the 2018 survey. And so this is what I plot on the next plot, with the forecast and the survey overlaid on top of each other. The coloured pixels in the background are the habitat as we forecast it in January 2018. And the circles and crosses correspond to the density of blue whiting adults that were observed in the March 2018 survey, 2 to 3 months after we made our forecast. And so what we can see is that there's actually quite good agreement between these two, particularly in terms of the east-west direction. And the forecast really actually has done a good job of reproducing this edge of the distribution shown here. Where we haven't done so well is in the northern part of the distribution, particularly with these adults observed up here around Faroes and the Shetland Islands. But we believe that these adults are most likely adults that are either migrating to the spawning grounds or are actually returning from the spawning grounds again after having spawned. And of course, these are not actively spawning adults, and so they're therefore not included in our forecast system. So overall, we're actually quite satisfied with these results. We see there's good overall qualitative agreement between the forecast and the observations. So based on that, we then have proceeded to repeat the exercise for 2019. And this is the forecast for this coming March that we see here. And we can see that it looks very much like the 2018 forecast, with the spawning habitat very compacted up against the continental shelf edge. We can try and understand this a little bit better by comparing it to the long-term average distribution, which is shown here as an anomaly. And these blue areas really correspond to and really indicate that we expect to see much, much fewer fish than average on the Rockall Plateau region, and in fact we don't expect to see any fish out there at all. We can also characterize this distribution and put it in a historical context by calculating the area of the distribution and the westward extent, which I have here on the next slide. So on the horizontal axis we have time running all the way back to 1950, and the top panel shows the area of distribution that's been observed historically, and the bottom panel shows the westward extent in the historical context. And then the red dots that we've circled here and here correspond to the actual forecast that we've made for March 2019. And so we can see that we expect to have perhaps quite an average distribution in terms of the area, but it's certainly very compact and has a very low westward extent, and it's very compacted and compressed up against the continental shelf edge. Now, one of the fundamental questions, of course, about any forecast is whether or not it's actually useful. And there's a school of thought from meteorology that says that a useful forecast is one that's used to make decisions. And so that's something that we'd really like to challenge the scientific community to help us try and decide whether or not this is actually useful. In particular, we'd like to know whether or not this can be used in the survey planning process. And what can we do to make it more useful? Are there changes to the way that the model is parameterized? Are there changes to the way the forecast is communicated or expressed that could actually make it much more useful in a decision-making context? We'd also like to know on what timescales we'd like to have the forecast running. How far into the future do we need? Weeks or months or years, for example, of a forecast lead time for this to start to be useful to make decisions on. And we'd also like to try and start to think about and have a discussion about how the survey can be used to both refine the forecast, and vice versa, how the forecast can be used to help refine the survey, in particular in terms of both spatial coverage and perhaps focusing on hotspot areas of high concentration. So with that, I'll sum up. We have here our forecast map. The forecast says or suggests that we're going to have a very compacted distribution up against the continental shelf edge with little or no spawning out here on the Rockall Plateau region. If you'd like to have more details or read some more about it, you can go into our website, fishforecasts.dtu.dk, where all the details are presented there, along with other forecasts that we've also produced. If you have some questions, some queries, some comments or theories that you'd like to discuss, please feel free to contact me. Both my email and my Twitter account are here. And otherwise, I thank you for your attention.